Good morning, mathematicians. In our previous unit, the one that we finished just before break, we looked at how we can prove that pairs of triangles are similar to one another. We looked at the angle-angle similarity postulate. We looked at side-angle-side similarity. And we realized that we did not have to measure all three pair of corresponding angles and all three pair of corresponding sides to determine similarity. In this next unit, we are going to look at congruency. How can we look at two triangles and prove that they are congruent to one another without necessarily measuring all three pair of corresponding angles and all three pair of corresponding sides? So in front of you, you see some combinations of sides and angles in triangles. And my question is, do any of these 6 possible cases turn out to be congruence shortcuts? Meaning, are these combinations that we can use to determine congruency between two triangles without having to measure every pair of corresponding sides and every pair of corresponding angles? So I'd like for you to pause the video for a moment, write down everything that you see on this page. Leave yourself a little bit of room for each of these possible cases so that you can continue. All right, I'd like to start by looking at the possibility of knowing the measurements of the three pair of corresponding sides, or the side-side-side congruency possibility. So you see in front of us we have the 3 segments measured out for us: segment AB, segment BC, and segment AC. So we're going to construct a triangle using these segments by connecting point B to point B. And you see how this is working out for us. We'll connect point A to point A, and then C to C. So now we're going to take those exact same 3 segment measurements and try to construct a different triangle, one that is not congruent to triangle ABC. So we're going to connect the points again. And we can flip this, we can rotate. When you look at this pair of triangles, you realize that we've created a pair of congruent triangles. We can try to do this again, but no matter what we do with these 3 particular segments, we're going to get congruent triangles. So if we have the 3 pair of corresponding sides measured out, and we know that the corresponding sides are congruent, that by side-side-side congruency, we know that the 2 triangles are going to be congruent. The next combination that we looked at was side, angle, side. Now notice the angle is in between the 2 sides that we're talking about. So if we pick side AB and side BC, we have to choose angle B because that's the point that's between those 2 segments. So for side, angle, side, if we have side AB, angle B, and then side BC, we're going to get this particular triangle. So we'll try this again, the exact same measurements. We have side JS, angle S, and then side SP. If I use those exact side measurements, that angle measurement, when I get my second triangle, we find that we've created a triangle that is congruent to the first. And this is similar to side, side, side. No matter how we try this with this particular set of side measurements and this particular angle measurement, we are going to wind up with congruent triangles. So the side, angle, side combination actually works out as a congruency shortcut as well. If we flip this one, like I said, there's that congruent triangle. The third combination in your notes is angle, side, angle. Now the side that we're talking about is in between the angles. So if we choose angles A and B, we have to choose segment AB. It's the side in between. So we'll do what we've been doing, and we'll construct the triangle with this combination. And then we're going to take the exact same angle measurement, the exact same side measurement, and try to construct another triangle that is not congruent. But in doing so, we see that we construct a congruent triangle without really trying. Angle, side, angle is like the previous two combinations that we've seen. No matter what we do, given a particular side measurement and the angles on each end of that segment, we're going to only create congruent triangles. So in terms of triangle congruencies, the angle, side, angle combination works for us as well. The next combination is side, angle, angle. Now in this case, you notice the side is not in between the two angles. So we can choose side AB. We can choose one of the angles, either angle A or angle B, and I'll just take angle A in this case. But then we're going to choose angle C. It's not on the other end of that segment. So now if we take angle A and place it at the end of BA, and then angle C has to be up here somewhere, but we need to get one of the legs of that ray to be on angle or side A or side BA, or running into side B. And you'll notice I have to move down a little bit to get this triangle to be created. Doing the same thing, we're given the side EU, angle U, which is at one end of this segment, and then angle M, which is going to be that third angle. I need to turn this a little bit. I'm going to make sure that one of the rays of this angle aligns with the ray off of angle U. If I move that down until I hit point E, without really trying, I create a congruent triangle. So this angle, angle, side, where the side is not in between the angles in question, does create congruent triangles consistently for us. And again, no matter how you try this same situation is going to occur. So at this point, we've investigated 4 possibilities for shortcuts for triangle congruency. Our 5th combination is side, side, angle. So we'll take side AB, side BC, so side, side, and then we just cannot take angle B, because angle B would be the angle in between AB and BC. So I'm going to take C. You could take A or C in this case. We're going to try to construct a triangle by connecting point B to point B. We'll put angle C where it belongs, at point C. And then we need to move the segment so that we get a triangle. We're going to try that again. Exact same side measurements, exact same angle measurement. And again, the goal is to create a congruent triangle, actually to try to not make a congruent triangle. So if I swing this leg in now, I have another triangle, but all of a sudden I did not create a congruent triangle. And as long as you can show one case where this combination of sides and angles does not create a congruent triangle, you've shown that this is not a congruency shortcut. So the side-side angle combination does not work for us as a shortcut. The last combination is angle, 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 and this should be ringing a bell with you because we have worked with something like this before. If we're given 3 angles of a triangle and we use them to create an initial triangle. Okay, we can slide this over. Now we're going to take those exact same 3 angle measurements and see if we can create a triangle that is not congruent to triangle ABC. And you can see right away, it's pretty easy to do. Okay, so I have a pair of triangles, the side lengths are the same, but the dimension, the side lengths are not the same, but the angles are the same. We do not have a pair of congruent triangles. Now, if you think about back to our last unit when we talked about similarity, we had the angle similarity postulate. We had the third angles theorem that said that if you know that 2 pair in a pair of triangle, or 2 angle pairs in a pair of triangles are congruent, then the third pair has to be. You can realize that angle would allow us to see similarity between a pair of triangles, but not necessarily congruency. So let's go back to recap the 6 possible cases. As we did our investigation, the first 4 combinations worked to create congruent triangles consistently. So side, 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 angle, side, angle, and side, angle all work as congruency shortcuts. The side angle doesn't work for us. However, as we get into investigating right triangles and congruency between, we're going to find that that right triangle is going to give us a special case for that. And then finally, the angle actually goes back to the similarity work that we were doing in the previous chapter. So update your notes, please. Mark the 4 combinations that work as congruency shortcuts between triangles. And then we'll go on and do some practice together.